we need to talk about is with the radical, if you are dealing with fractions, it is not proper notation to leave a radical on the denominator. So if you have a radical on the denominator, we have to do what's called rationalizing, or moving that radical off the bottom. So let's look at this. What would you do to get that square root of 3 off the bottom of the fraction?
Multiply both sides of the fraction by the square root of 3.
Okay. So we know we can't change the original problem. So whatever we do, it has to be mathematically equivalent. So with fractions, if you do something to the bottom, you have to do it to the top as well. So if I multiply by the square root of 3 on the bottom, we do it on the top. So 1 times the square root of 3 is the square root of 3. On the bottom, square root of 3 times the square root of 3, we talked about multiplying those, how you can multiply the 3's together. But what is the square root of 9? So this is the square root of 3 over 3. If you looked at like decimals, 1 divided by the square root of 3 and square root of 3 over 3, it's the same decimal equivalent, so we didn't change the problem, we just rewrote it. Let's get another one. 5 over 4 square root of 2. Alright, so we have to get rid of the radical on the bottom. So the 4 is not a problem, just the 2. This is all one term because there is no addition or subtraction. So we're going to do the same strategy. We're just multiplying, same thing on top and bottom. But all you have to do is the square root part. So if I do that, on the bottom, or on the top, I have a 5 square root of 2. On the bottom, if you multiply, you would get 4 square root of 4. What is the square root of 4? 2. So what that means is 4 times 2, or 8. Okay. All right. How is this one different? We have 2 terms on the bottom. A square root of 3 minus a square root of 2. So 2 terms. Don't write this down yet. If I just multiplied by the same thing, so what we've been doing to get rid of a radical is multiply it by itself. So if I did that here, what would you have to do to multiply the bottom? FOIL. So we have the square root of 3 times the square root of 3, so that would give me a square root of 9, minus square root of 6, minus the square root of 6, so minus 2 square root of 6, plus the square root of 4. Now the square root of 9 and the square root of 4, those reduce, but does the square root of 6? No. So it didn't get rid of our problem because we still have a radical. So I can't just multiply by the same thing. Do you have another idea? You might mean this right thing, just call it wrong. So basically what we need is, for when we FOIL, we want that middle term to drop out, right? That happens when you multiply by what's called the conjugate, which is the same thing except you change the sign in the middle. So since this one was a minus, I'm going to multiply by the plus. All right, we have to distribute. So on the top, square root of 2 times the square root of 3, that's the square root of 6, plus the square root of 4. On the bottom, when you FOIL, you get the square root of 9, plus the square root of 6, and minus the square root of 6. Cancel. Minus the square root of 4. Alright, so square root of 6 plus the square root of 4 is just 2. On the bottom, this is 3 minus 2. What is 3 minus 2? 1. And anything over itself, or over 1, is just itself. So we just get the square root of 6 plus 2. I want to give you guys one of those to try. So multiply by the conjugate, which would be 5 plus the square root of 2. So on the top, 3 times 5 is 15. 3 times the square root of 2 is 3 square root of 2. On the bottom, 5 times 5 is 25. Minus, or plus 5 radical 2 and minus 5 radical 2 cancel. Minus the square root of 2 times the square root of 2. So square root of 4, which is just 2. So we have 15 plus 3 radical 2 over 23. Are those okay? Let's talk about if it's not just a square root. So if I ask you to rationalize this, okay, there's a couple different ways of thinking about this one. We know we need the radical to get off the denominator. We're dealing with cube roots, so we're going to have to multiply by the cube root of something on top and bottom. Some people like to just think about perfect cubes. So like 2 to the third is 8. Can you do 3 times something to get 8? No. 3 to the third is 27. Can you do 3 times something to get 27? Yeah. What would it need to be? 9. So on the top, I just have 4 cube root of 9. On the bottom, I get the cube root of 27. But what is the cube root of 27? So that would be the final answer. Another way of thinking about it, so if this way makes sense, you're welcome to just tune me out for a second. We currently have 1, 3. Because it's a cube root, how many of them do you need before you can pull it out of the radical? 3. We have 1, so we would need 2 more. Now 3 squared is just 9. There's just another way of thinking about it. So we have 4 cube root of 3 squared, which is 9, over the cube root of 3 to the third, which is just 3. So whichever way you guys prefer. Okay. This is the same thing as saying the 4th root of 3 over the 4th root of 5. We don't care about the radical on the top, but we need to get it off the bottom. are we going to do? Mm-hmm. We have 1 5, we need 4 of them. So we need 3 more, or 5 to the third is 125. On the top we get the fourth root of 375. On the bottom that's the fourth root of what is the fourth root of 625? Any questions on that? Last couple examples. In order to add or subtract fractions, what do we have to have? Common denominator. So we need a common denominator to subtract them. We're also going to have to ultimately get the radicals off the denominators. So we have a couple different things that we're going to do here. The square root of 12, can that be reduced? Okay, let's break down these radicals before we try to do anything else, so we're not creating extra work for ourselves. So square root of 12, you could break that into a square root of 4 and a square root of 3. Square root of 4 is 2. Okay, square root of 27, radical 9, radical 3. So that's a 3 radical 3. What do you notice about the first one? What happens with those 2's? Okay, so we've reduced our radicals. Now we still need common denominator and get the radical off the bottom. Let's do the common denominator first. What would I have to do to give them the same denominator?
Multiply the first one by 3.
Do it on top and bottom. So 3 minus 1 is 2 over 3 radical 3. And now to get the radical off the bottom, what do we do? So we get 2 radical 3. This would be 3 times the square root of 9. So 3 times 3, which is 9. Any questions on that one? Last one. Sorry, that's kind of blurry. Yes. lots of different possible starting points. Let's look at the top first. We have these two cube roots being multiplied together. So let's go ahead and do that. So when we multiply them, it's still a cube root. 8 times 2, 16. M squared times m squared. M to the 4. And n cubed over my denominator. From here, there's actually two different options. One is going to be a lot easier than the other. They'll both get us to the right answer, just one would save a bunch of time. What are your thoughts from here? Since both of these are under the cube root, we could go ahead and reduce them. So 16 and 32, 16, or 32 divided by 16 is 2, so that leaves us a 2. What happens to the m to the 4th? They cancel. What about the n cubes? So all we are left with, if everything cancels on the top, that just leaves us a 1. So we have 1 over the cube root of 2. We need to make it a perfect cube. So what would I have to multiply by? So 1 times the cube root of 4 would be the cube root of 4 over the cube root of 8 or cube root of 4 over 2. Do you guys have questions for me? So that is really the end of this section. Game plan, you guys have time right now to finish up that handout that's due tomorrow. And you know, if you get done, you can welcome to check yourself in the folder. Tomorrow we're probably just going to review sections 5 and 6 a little bit more. I'm not confident that we're great on those yet, so I just want to take a little extra time reviewing all those rational exponents and radicals. And then we are probably looking at a quiz on Wednesday over these two sections. So we'll review tomorrow quickly.